Hello everyone, welcome to part 4 of Numpy. Today we are going to discuss functions and arithmetic operations on Numpy. Some of the functions which are very useful, and these are provided by Numpy array, and it will give you a great deal of ease to work with Numpy. But remember, these are only some of the examples which are listed in CBSE books. So first of all, we are going to have a trigonometric functions. For example, sine x, cos x, tan x. Here x is our array. And there are also other functions like AR, arcsine, arccos, arctan, and etc. You can check out whole list of the function in Python documents. So let us see how this function works. So first of all, we will be seeing sine, and let us jump to our IDE and check out. So we have a function, and we have used b is equals to np dot sine, and we have to specify a, and let us print this value, print a slash n, copy, paste, and b, let's change this to b, and see sine values. Execute this one. So now you can see our array. We have array A, which contains 1 2 3 4 5 6 up to 24, and our B contains sine of 1, sine of 2, sine of 3, so on up to 24. Okay, we can try it for cos as well. For example, C is equals to np dot cos A, let's say, and let us print this one. So now you can see we have sine values as well as cos values. So now let us jump to our presentation and see what are other functions. Now a round, we can apply same concept to these functions also. I'm just going to explain you what are the functions. A round, as the name is self-descriptive, it rounds to a number it evenly rounds to a given number of decimals. Rint rounds an element to array of the nearest integer. Fix rounds to nearest integer towards 0. Floor returns the number of input element wise. These are all functions you have to do practically and understand how these can be done. Okay, so I will show you how this rint or round int works, and you can apply the same concept for other functions. Okay, so let us get rid of this and this, and let's say in place of sine rint, and we are going to have some float values. Let's say 1 to 5, linspace, comma, let's say 10 elements, and let's forget about reshape, and let's print a and b. Let's print this one. So now I have used linspace to generate random values within the range 1 to 5. So these are the 10 elements with all the decimal values. I have used our round integer. So basically these are round to 4.55 is rounded to 5, and so on. 1 is rounded to 1, 1.44 rounded to 1, and 1.8 is rounded to 2. So basically it is rounded to nearest possible integer. Okay, now some more functions are there which are very useful. For example, if in an array I want to find out the maximum value, so what I can do is np dot max of, let's say, a, and let us try to execute this one and see 5.0. We have seen the maximum value is 5. Similarly, we can specify it to mean as well as 1. So this is really very easy. If you want to find minimum or maximum values, you can use all these. You can also find mean values. Mean, see, mean is 3.0 for the value. You can calculate it. I'm not going to calculate this one. You can use other statical functions like median, and let us execute this one and see. I think it's very clear. You can have sum function as well. See, sum, and there are many other functions. We have some mathematical function like add a comma 2, and let us print this one. See, 2 is added to all the elements. Similarly, we have subtract as well. A2, let's say, execute it. First value was 1 and we have subtracted 2, so it's now -1. You can see it is done to all the elements. So we have many other functions like let's say, if I tell you this, we have C, we can use multiply or divide. C, I have to print. Now you can see all the array elements are multiplied by 2. So this is really very simple to work with Numpy array, because it provides many functions which will give you ease in working, and the things which are very tedious in other programming languages are piece of cake in Python. So now let us jump to our next topics. You can try all the functions. Now, application of an array, Numpy array. In CBSE we have to learn actually 3 functions which are generally used as an application of Numpy to calculate covariance, correlation and linear regression. So let us first of all understand what is covariance. Is a method which tells us how two data sets are different. If the result is positive, highly positive, that means the two data sets are very similar, and if it is very negative, then it means that the two sets are very dissimilar. Similarly, next is our correlation. It is done with the help of a function CORF, or you can say that correlation coefficient. It is similar to covariance, but the thing is, it is used to only check whether they are different or not. Means it will not tell you how they are different, but it will tell you these are different or similar, or it's so that's why it gives only 2 values. Positive one, that means it is positive covariance, that means these are somewhat similar or maybe similar in some manner. These are similar, but negative values says that these are dissimilar or negative covariance. Now the third is linear regression. Actually, linear regression is a method used to find a relationship between a dependent variable and a set of independent variable. Numpy polyfit xy, degree is used to calculate linear regression. X and y are the two data sets, trying to find out how x is dependent upon y or y is dependent upon x, and we will find out key possible value of x, yeah, known value of x. For a known value of x, what will be the value of y? Okay, so basically linear regression will tell you the dependency of a x relation to y or y relation to x. So let us see how these can be done. Let's say we have a is equals to np dot array. We are going to take some values 1, 2, 3, 4 and 5, and we have b is equals to np dot array with some more values. 3 comma 4 comma 0 comma -1 comma -3. Okay, so first of all we are going to calculate correlation. Covariance is equals to, let's say, so now let us try to execute this and see. So now what we get is a two-dimensional array containing 4 elements, and here this value, that is 0 by 1 and 1 by 0, are similar, and these are called covariance. Okay, so if you want to calculate covariance of x, y and y, you have to say np.cov a comma b. So if I want to print covariance is equals to, I have to print somewhat like this, covs is equals to 0 comma 1. So your 0 and 1 element contains the covariance. Let us print this one and see. So this is how we can calculate covariance. This is really very important because it is specifically specified by CBSE in this syllabus that covariance is in your syllabus. Okay, next we are going to learn correlation coefficient. So let us now calculate correlation constant. So let us now calculate correlation coefficient. So correlation is equals to, let's say, np dot correlation coefficient of a comma b. Again this will contain a matrix of 2 by 2. So print one core, and now to print correlation coefficient, a and b is, let's say, core 0 comma 1. So let us execute and check. See, so basically this also contains this two-dimensional array containing positive and negative values. So here in this case 0 by 1 or 1 by 0 tells you correlation of a and b. So if an examination question is there to calculate correlation or covariance, you have to print only the 0 by 1 or 1 by 0 element for covariance and correlation. This is really very important. So now let us cover our next topic, which is calculating linear regression. As we have discussed earlier, that we want to find out how a and b are dependent, or what will be the value of a when we have some value of b. Okay, so let us see how we can do it. So we have, let's say, p is equals to np dot polyfit we specify both our array a and b, comma, let's say degree is equals to 1. And now I want to find out, so first of all let us print